This is Sir Rajesh Chimnani, lecturer, chemistry, Government Degree College, Nirpurnathelu, District Godki. Today I will deliver lecture on the topic belongs to first year chemistry. The topic is stoichiometry. Students, the word stoichiometry is combination of two words. One is called stoichion, which means element, and other is metron, which means measurement. So, in this is a branch of chemistry. Its definition is the branch of chemistry which deals with the quantitative relationship between amounts of reactants and products in a balanced chemical equation. So its definition is looking little bit complicated, but it is not complicated, it is easy one. I'll make it easy. So the branch of chemistry which deals with the quantitative relationship between amounts of reactants and products in a balanced chemical equation. So we will discuss this definition in the following examples. Before going to examples, here we are going to explain what is the meaning of this definition. First of all, you must be familiar with what is a chemical reaction. A chemical reaction is an actual chemical change that is undergone by the substance called reactants. The reactants undergoes a chemical change and they are converted into a new substance with different composition. The resulting materials are called products, and the starting materials which have undergone the chemical change, they are called reactants. So here nitrogen and hydrogen are the reactants and this ammonia molecule is the product. These are the reactants, starting material, and ammonia is the product. This is the resulting material. And we should also be familiar with what is the balanced and unbalanced equation. What is a chemical equation? Chemical equation is a way of writing an actual chemical change in the form of symbols and chemical formulas. There are two ways of writing chemical equation. One is descriptive method. We may write this thing as when nitrogen reacts with hydrogen, it produces ammonia. This is a descriptive method. We write the occurrence of reaction in words, that when nitrogen reacts with hydrogen, it produces ammonia. And other way is that we have used symbols and chemical formulas. Instead of writing nitrogen in words, we have written nitrogen. Instead of writing hydrogen in words, we have written the molecular formula of hydrogen and molecular formula of ammonia. This way of representing a chemical change is called chemical equation. So what is chemical equation? The symbolic representation of a chemical change is called chemical equation. Chemical equation has two parts. One is called reactant. This part belongs to reactant and this part belongs to products. And the reactants and products are differentiated by an arrow. An arrow differentiates which one is a reactant and which one is a product. At the left side of the arrow, there are reactants, and right side of the arrow, there are products. Now, a chemical equation may be a balanced equation or unbalanced equation. What is balanced equation and what is unbalanced equation? Here we discuss nitrogen reacts with hydrogen, produces ammonia. Now, there are two nitrogen atoms, two hydrogen atoms in the reactant side, but at product side there is one nitrogen and three hydrogen. So here there were two nitrogen atoms, but reactant, but in product there is one nitrogen. It means the same atoms are identical elements. Atoms are not equal in both reactants and products. So an equation which have unequal number of similar or identical atoms in both reactants and products is called an unbalanced equation. So here this equation is unbalanced. Another feature of unbalanced equation is that when you write masses below the atoms involved in the equation, you find that the masses will be unequal. The total mass of reactant should not be equal to the total mass of product. Look at here. Nitrogen weighs 28 gram, hydrogen weighs 2 gram. So 28 plus 2 is equal to 30. Nitrogen weighs 14 gram, hydrogen weighs 1 gram. So 14 plus 3 is equal to 17. Now 30 gram is not equal to 17. It means the masses of reactants are not equal to the masses of products. This confirms that the number of identical atoms in reactants and products, they are not same. When they are not same, their masses are, total mass of reactants is not equal to the mass of product. The equation is considered as unbalanced equation. Now look at here, the same equation, nitrogen, hydrogen, nitrogen. There are 2 atoms of nitrogen, 6 atoms of hydrogen, 2, 3, 6, 2n, 2 nitrogen atoms and 6 hydrogen atoms. So in reactant there were 2 nitrogen, 6 hydrogens. In product there are 2 nitrogen and 6 hydrogens. It means the identical elements in both reactants and products are equal. This equation is called a balance equation. And another identification of balance equation is that the total masses of reactants and products are always equal. How? 1 mole is involved in the equation. 1 mole of nitrogen weighs 28 gram and 3 moles of hydrogen weighs 6 gram. So total 28 plus 6 becomes 34. 2 moles of ammonia. Ammonia weighs 17 gram. How 17 gram? 14 for nitrogen, 3 for hydrogen, exactly 17. 1 mole of ammonia weighs 17, so there are 2 moles, so the total mass will be 34. Look at here, 34 grams of nitrogen are equal to the 34 grams of ammonia. Sorry, the reactant mass is equal to the product mass. So this equation is considered as a balanced chemical equation. This is an unbalanced equation. Hopefully you might have familiar with what is a balanced equation and unbalanced equation, what is a reactant and what is a product, what is a chemical equation. So a balanced equation is that equation which has equal number of identical elements in both reactants and products, and the total mass of reactants is equal to the total mass of product. In unbalanced equation does not have equal number of identical atoms in both reactants and products. So here now we will turn towards the definition, that what is the meaning of definition of stoichiometry, what it explains. Consider a simple example, carbon plus oxygen, carbon dioxide. 1 mole of carbon is involved, 1 mole of oxygen is involved, and 1 mole of carbon dioxide is formed. In other words, we say 12 grams of carbon, 32 grams of oxygen, and 44 grams of carbon dioxide are formed. This is a balance equation as 1 carbon here, 1 carbon here, 2 oxygen here, 2 oxygen here. So the masses are equal, it means this equation is a balanced. Now come to the definition. It says that the quantitative relationship between amount of reactants and products in a balance equation. What is the explanatory meaning of this sentence? Let's see. 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. This is our balance equation. Now, if we have 2 moles of carbon, what moles of oxygen are required to completely react with 2 moles, and what moles of carbon dioxide are found? We can guess from the given information what is given in the balance equation. Balance equation is a reference equation from which comparison is made. So we will make comparison from this equation. As balance equation guides us that 1 mole reacts with 1 mole of oxygen, 1 mole of carbon reacts with 1 mole of oxygen. Therefore, 2 moles will react with 2 moles. Similarly, 1 mole of carbon produces 1 mole of carbon dioxide. Therefore, if we have 2 moles of carbon, we will have 2 moles of carbon dioxide. So this relationship, which relationship? We are given moles of one reactant, we have find moles of other reactant and the moles of product from what? One thing that was given. So this relationship by which we can find the moles are the amount of one reactant, other reactant from the given reactant, or product by comparing it with a balance equation. This comparison is called stoichiometry, that how we predict or how can we calculate the amount of product or reactant if one thing is given. Either we will have reactant is given or product is given. Both things are possible, both things may be given in the problem, but we can do in both ways. Now, if the branch of chemistry deals with the quantitative relationship between the amounts of reactants and products in a balance equation. This was the balance equation. Balance equation guided us that one mole reacts with one mole. Therefore, we were given 2 moles, then 2 moles will react with 2 moles. So for 2 moles of oxygen are required, and 1 mole of carbon produces 1 mole of carbon dioxide, therefore 2 moles will produce 2 moles. In this way, this definition has been explained. After that, assumptions, that what are the main points while doing stoichiometric calculations. We have to keep these 4 things in our mind while doing stoichiometric calculations or problems regarding the stoichiometry. What are these? Number 1 is that the reactants are completely converted into products. The reactants are completely converted into products. For example, take example of this equation. If we are given 12 grams of carbon, we must assume, we should assume that 44 grams of carbon dioxide will be formed. Only if 12 grams are given, the maximum we will have 44 grams. But if the reaction has not been finished, it means that the all amount of reactants has not been converted into product. It means, say, if out of 12 grams, only 8 grams are converted into carbon dioxide, can we get the 44 grams from 8 grams? No. 12 grams exactly, if we will have 12 grams exactly, we can have 44 grams. But if the reaction has not been finished, only 8 grams has been consumed and 4 are remain unreacted. So we won't have 44 grams. So this is what we have to wait for the exact amount of product. An exact calculation, we have to wait until the completion of reaction. The reaction must be completed. The given amount of reactants must be converted into products. So if we don't follow this assumption, our answer will be wrong. Come to the second point, the chemical equation must be balanced. We discussed just before that in a balance equation, the total mass of reactant is equal to the total mass of product. When this mass is unequal, the equation is unbalanced. So until and unless our equation is not balanced, our calculation can never be correct calculation. So we have to watch the chemical equation that we are given. That if it is unbalanced, we have to balance that equation before going for a stoichiometric calculation. An unbalanced equation cannot give you an exact amount of product. Law of conservation of mass must be followed. Law of conservation of mass states that mass is neither created nor destroyed. It can be changed from one form to other form. In other words, we say the total mass of reactants must be equal to the total mass of product. And you know that it's only possible if the chemical equation is balanced. So in a balanced chemical equation, the total mass is equal to the total mass of product. Reactant is total mass of reactant is exactly equal to the product. So if equation is balanced, this law will also be followed. So side reaction should be stopped or avoided. If side reaction occurs, so in this case, what to do? We have to stop that reaction. If otherwise, we cannot get an exact amount what we are doing for. For example, carbon plus oxygen, carbon dioxide. If the oxygen is in excess, this will be the main product. This will be the only product. If oxygen is limited, carbon monoxide is also produced as a side product. This is side product. Side product. If the oxygen is limited. Now, if we have 12 grams of carbon and we are assuming that we must have 44 grams of carbon dioxide from 12 gram. But if carbon monoxide is in between carbon and carbon dioxide, it is also being formed, then we never get exact amount of 44 gram. So that is why if side reaction occurs, we have to stop this reaction, because some of the grams from carbon has been converted into carbon monoxide. That mass of carbon will be missing in the carbon dioxide. So we are assuming 44 grams from exactly 12 grams, exactly 44 grams from 12 grams. But if side reaction occurs, we won't have this exact amount, 44 grams. So this is why we have to stop the side reaction.